Welcome to a lesson with Dr. Powell. Let's take a look at an application of adding up the terms of a geometric sum. Namely, what if we make deposits into an account that's accruing interest at 3% compounded each month? So that means 12 times a year. So every time we compound each month, we're multiplying by 1 plus 0.03 divided by 12. That's what we're multiplying by each month. We'll call that R, capital R, common ratio, but I'll use a capital R so we don't confuse it with a lowercase r, which is percent interest in this case, and they're two different things. Here, this common ratio thing is the thing we're multiplying by every time in a geometric sequence, and we'll let it be 1.0025. And let's see what happens. The first month, we make a deposit. The second month, we make another deposit. And the deposit we made last month accrues interest. We compound it once. Now, the month following, we make another deposit. The deposit we made last month is we compound it once, so we multiply it by R once. And then the next time, and then the first deposit that we made has been compounded twice. So the total amount is actually 100 plus 100 times this R plus 100 times this R squared. It's the beginning of a sum of a geometric sequence. So if we look at that, we think, well, what happens after 20 years? Well, notice that we're adding one thing first month, two things second month, three things third month. So it makes sense that after 20 years, we'd be adding 20 times 12, which is 240 terms. So we'd have 240 terms to add in a geometric sequence. To remember, the two things we need to find the sum in a geometric of the terms in a geometric sequence is what the first term is. In this case, each time it's just 100 as we go down the list. So at the end, it will also be to 100 multiplied by the number of terms. Well, there'll be 240 terms at that point that we're adding on that line. So 100, and then we have 240, and then our R value, our capital R value is that for a common ratio. We just put that in so that R raised to the number of terms minus 1, all divided by R minus 1, multiplied by the first term. And that will yield about $32,830.20. I put approximate because really there's a decimal that goes after this and it rounds to this cent value. But if we're okay with the cent value, then I suppose it would be equal. So we actually have that after 20 years of just starting with making a $100 deposit every month at this particular compound interest rate, we would end up with $32,000 in $32,830.20. Thanks for watching.